We're back outside again, and today we're going to look at what a traverse is, how we would run a traverse, and once we have the traverse in place, we can use radial layout to lay out our building corners or anything on the job site. We can lay out if we know 2 points, and if we have a traverse, which is just a set of points that create a geometric shape, or really just a geometric shape that shows the confines of where the building's going to be located. So what we would do is the survey crew would come out and would lay out our traverse, which again is a set of points that we reference.
So it doesn't have to be a square, it doesn't have to be a rectangle.
It could be multifaceted, because look, if we look around where we're at today, we have trees, we have buildings, we have utilities.
Right.
So you may have to break. If you can't run a rectangle, it would be great to have a rectangle for your traverse, but because of the lay of the land, you may have to have a multifaceted side.
Yeah, it could be hexagons, octagons,
right,
long legs, all kinds of things.
So in the old days, we would go out and we'd run our traverse with our prints, we would set our points, and then we would have to use turn angles with our instrument, and we might have to chain those distances.
Sure.
So what we do is we give the contractor the traverse on the civil prints, right? Say Schneider Engineering, who is a large surveying company here in town, on that print you would see their traverse.
Okay.
And you would actually go out and locate those traverse points, because they're going to have a lath by a hub with a nail in the hub designating the coordinate, right? That point in
that
space.
nail in the hub.
And once they locate those hubs, then we can set up and we can make sure that our traverse is proper.
Okay.
So that everything's on the blueprint, the angle, the distance between hubs, all has to be verified, right? Because what do? We always check our work.
Sure. So we're checking the survey crew's traverse,
right,
and then we can set points off of that to establish a manhole location or whatever we need to establish, but we're using those as kind of our benchmarks to work our way in closer in on the site.
Right. So the traverse gives us the boundaries,
okay,
and useful data points, so that we can set up on those points, back shot to get a straight line on, shoot our line of sight, and then we'll start to follow the angle, to where the building corners are. So I shouldn't say follow the angle. We're going to use turning angles and distance, measuring distance, to set coordinates for our structures.
Okay. And that's where you were talking about in our earlier sequence about the T16, about the vernier and being able to carry an angle with you.
Right.
That's what this is all leading up to.
Yes, it is, because what we're going to do today is we're going to show you, we'll introduce half of the process in radial layout. We will turn angles, but we're going to already have existing points to show the process of turning angles. The T16 being an old optical unit, today we use digital theodolites.
Okay.
And they're called, one product is a total station. And what it does is it combines the ability to both shoot angle and distance off of the same unit. The T16 as it stands right now is just for turning angles.
Okay. No distance capability.
And we could lock this scope in level, and then we could use it as a builder's level.
Sure.
And do differential leveling.
Okay.
So this unit has one special feature, because the time that this was really in use, you could set a secondary unit, and you can see we kind of have
a
pin,
locking device.
Right, so that we could set what's called an EDM on top of it, or an electronic distance measurement tool. And that actually, when you mount this properly, it will actually shoot a beam out that's picked up by a prism.
Okay.
And shoots back, and then you're in constant communication between person running the instrument and the person that's out on the prism, because that's actually going to tell where that prism needs to go, because what we're trying to find out is at the angle and the distance, we have to be able to drop a hub into the ground and then put a nail right where that point is.
So with the units that are in use now, yes, on a regular basis, that's all built into the same system. Okay.
The total stations that you guys will be introduced to next year do it all in one unit. Much easier.
Sure.
Much easier. And now technology's gotten to the point where now we're using robotic total stations where it's just a one-person game.
Yeah, drones, surveying. Yeah.
For surveying, GPS now. So what we've done is with technology, we're cutting down our crew sizes.
Yep.
So when it's just one person going out there,
picking up speed now.
We're talking about efficiency, GPS. I mean, it's just going out, setting up, and taking your bench, and off you go.
Yeah. Which is still not without its
Right.
problems if we haven't done proper calibration of those instruments, things like that.
Yeah.
So no system is perfect.
Absolutely. There's always, in surveying, you keep hearing us say that we're always trying to minimize human error and mechanical error.
Sure.
Okay, so you can see that we've already set up over a point. What I want to demonstrate to you guys today is the process by which we turn an angle, we hold the vernier in place, we come back around, flip our scope, and take the angle again. We'll actually do that 4 times. We'll actually take 4 shots on one angle. Why, Mark? Why do we do that?
Because we want to be able to eliminate some of the error
Right.
in the person running the scope. Maybe they did not, or the T16, maybe they didn't hit the point exactly in the crosshairs. But we also know there's always some error in the optics themselves.
Certainly can be,
because
yeah.
we can only grind the optics to such a fine degree.
Right, right. So in this instrument, it's very easy to set up wrong. All of these are just so finely tuned that when you just barely touch something, it can take it out of level. Now what happens when it's out of level is if we're shooting 20, 30 feet, that out of level, that distance where it's going to shoot wrong, the error may not be much. It may be thousandths of an inch in 20, 30 feet.
Right.
But what happens to that error when we shoot 1,000 or 2,000 feet, right?
Sure.
So the order of magnitude of the error starts to increase the further we go away from the instrument. So we have to do some things to eliminate that.
Right.
The first thing we can do is make sure that our setup is proper, that we're where we need to be with the instrument. Everything, the bubbles in the middle of the vials.
Right, so we can refer back to our earlier video where we properly level our tripod, then we go to the bullseye or target level, then we work through the sequence of the vial level on top, or the torpedo level, and
Right.
set up and make sure that we're where we need to be. And remember, in the sequence, we don't move fast. The instrument setup is actually a pretty time-consuming process, but to be accurate, it has to be done.
And some other things that you got to be mindful of when you're out. As the sun comes up in the morning, especially in the fall and the winter, not so much in the winter when the ground's, frozen down 18 inches, 2 foot, 3 foot, but in the fall it's really bad. You'll get frost in the morning, so you'll get that, or it'll get cold, it'll go down under freezing, and you'll get a nice frozen layer, maybe an inch.
Little crust on top.
Right, a little crust on top. And you come in and you set your tripod up and you do your instrument setup, you do some work, and then you go over here to do something, or you're stepping back and you're doing your calculations, and the whole while the sun is beating down on this instrument and the ground below it. And what'll happen is the ground, as it thaws, our instrument will start to sink and it'll move. And once that happens, your setup is no longer good. You have to reset up the instrument and pick up back your line of sight.
Right.
so that you can move forward with precision.
So you want to continue to check out once you've got everything leveled. You need to refer back to those and make sure nothing's changed. Or if somebody goes by and kicks the tripod leg, or
And when you're doing several things at once, right? You know, we're shooting, we're recording data, you can kick it.
Sure.
And once that bubble comes out, then you have to redo what you just, did before you move forward.
Absolutely.
Okay, so the process we're going to use to turn angles is another way that we can minimize error. And we talked in a previous video about the setup and where the vernier is and how we control the movement of the vernier. So if we remember, we have this little flapper on it's just a little lever on the front of the housing of the unit. And when it's in the up position and you spin the instrument around the axis point, you'll start to read a degree change on the vernier scale.
And that's through the smaller scope.
Yes, the smaller optical scope. We have the mirror on the side of the unit. We have to open up the port, and then that allows the sun to reflect down into the housing and illuminate the vernier.
Okay.
So by being able to utilize this lever in the front, we can lock down the vernier and travel without having a degree of change. And that's crucial when we want to hold the angle, bring it around, and then we're going to flip the scope 180 degrees, and then I'm going to shoot the angle again, turn the angle again. By doing that, remember, Mark said earlier that when we're shooting, if we're out of level a little bit, we may shoot high. So to offset that, we need to shoot low on the next shot, right? So we flip the scope 180 degrees, hold the vernier, bring it around, set back up on our original point, open the vernier, okay, by flipping the lever up.
Right.
And then you'll turn your angle again. So if we shot a 56-degree angle, that second shot should be 112 thereabouts.
So we started at 0 on the vernier.
Right.
We turned an angle to 56 degrees.
Yep.
We locked it, we carried it back around, and it flipped the scope. So instead of starting from 0, we're starting at 56 because we carried the angle with us, and we unlock the vernier and we start climbing again in numbers, and if we've done our job right, we should hit at double the amount of 56, which is 112. And we'd want to do that 4 times.
Right.
Okay.
So you might end up with, 224, right? And then you divide that by 4 to get your average. So what we're always looking for are averages, because that's a much more precise way to equate something than just using one shot. If we're wrong, who cares?
So when I step up to the instrument and I want to find the vernier, I'm going to look through the small scope. I will use my mirror to illuminate inside the instrument. And right now, Scott, I'm seeing 356 on top and 003 on the bottom. And as I rotate, those numbers are changing. So where do we want to start?
We want to start at 000, right? If that's, some of the verniers are different in how they look,
sure,
right? But we want 000s, and that's where we start from. And with the, like I said before, there are 2 vernier scales in the T16. There's a top yellow one,
right,
and then there's a bottom one, I believe, that's white. The white is for horizontal, or the bottom scale is for horizontal movement, and then the top yellow one would be for zenith angles.
Zenith, okay.
And that means vertical angles off the horizon, whatever, okay? So why don't we just go ahead and show you guys the process. I think I'll have Mark go out so that I can locate. We've set up over a pin, and Mark's gonna go down line, stand on the back side of the pin so I can locate Mark with my scope, as scary as that sounds. And then I will sight down him until I find the pin, and then I'll be able to have my starting point.
And that's where you'd want to set 0 at that point.
No, I'll set 0 before I move to you.
And carry 0
right,
to that.
you.
There
that
we go.
way,
okay.
You know.
Now we're only 20 yards apart right now, so we're going to simulate like we're a greater distance. I'll take the story pole with me, because if I was a great distance away, we're not reading these numbers, but it gives another indicator for Scott to find me at a great distance. He can look for the colors, because I may be standing behind a group of dark trees, and maybe I'm not in high vis and he's having trouble finding me, but he'll be able to pick this up in the scope. So we'll go ahead and simulate a distance that's greater than what we're at.
Because that's very important, Mark, because if you don't have the object already in focus, it is very hard to locate, just because of what you said. I may not be in high vis, I'm blending in with everything.
The background, right.
And you can burn a lot of time trying to locate where the next person is.
Okay, I'll head on out.
It's a good point. All right, so what I'm going to do is I'm going to lock in my 0 on the vernier. Okay. So by flipping that lever down and taking it to 000, kind of a rule of thumb, you don't have to. You can certainly run things counterclockwise, but I always, when I was out working, I always work from left to right and clockwise when I'm surveying. It's just what I do. So what we're going to do now is I'm going to look down and I'm going to find Mark in the main scope, the main optics, and then I'm going to run down him and I'm going to shoot that pin. And once I lock in on that, I'll be able to open up my vernier, turn my angle, so he'll go down line to the second pin, and I will turn this first angle here. So I'm pretty close. I've locked him in pretty close. Now I'm going to use my fine adjustment like we described in the previous video. I locked that thumb screw in, and now the only way to turn that unit is by the fine adjustment up front here. So that's what I will do now. Okay, I found him. I've shot the first pin. So the vernier is locked at this point with the flap or the lever down. If I were to shoot without opening back up the vernier, it would just carry 000s until I found Mark, and I would not register anything on the vernier scale. So at this point, what I do now is I open up the vernier scale, flip the lever in the up position, and I start to turn my unit counterclockwise until I see that ugly mug in my viewfinder. Once again, I'll lock in the unit so it can't turn, so I have to use my fine adjustment. All right, so now we've registered our angle. What I would have done here now in my field book, I would record that angle. Now I'm going to lock the vernier again, because now that I've registered my angle, I don't want that to change. Because the next step in the process is where I flip my scope 180 degrees. So I just flipped the scope over to me. Now I'm going to go back over here, Mark. I'm going to find that pin again. Okay, so what I've done is I've carried that first angle back around, flipped the scope. Now I'm sitting on the original angle, or the original point rather. Now I'm going to open back up my vernier scale, and I'm going to turn the angle again. Okay, Mark, you can go. I've opened the vernier scale. Now I'll be able to compound the angle. That means if I was at 56 degrees and 34 minutes, 26 seconds, I'm going to turn that again, and whatever that angle is, now that I've flipped the scope, it's going to add that to the original 56-degree angle. That's called compounding the angle. So now I'm going to turn and I'm going to sight him in over here. Okay, I've got him. So I'm going to lock down my vernier again, because I'm going to carry that compound angle yet a third time. Okay, Mark? I flip my scope 180 degrees, and I'm ready to locate Mark again. Okay, I've got him. So Mark will travel over again. I'm going to open up my vernier so we can compound a third angle. Okay, I found him. So now that I've compounded the third angle, I'm going to lock down the vernier again. That's pushing the lever into the down position. So now I'm going to spin my unit again. I'm going to flip my scope for the fourth time. And once Mark sets up, we'll get him again. Okay, we've got him. Now we're going to turn the fourth angle in this series. I'm going to open back up the vernier so that I can compound the angle. So Mark is set up on point B. We're going to take the head over to him. I'm going to locate him. Lock down the travel so I can use my fine adjustment. Okay, great. So I'll lock down my vernier. I'm going to go in, I'll record, well, I would have recorded all of those 4 angles. I would take a sum of those 4 angles and divide it by 4 so that I could get the average angle shot of the 4 shots that we did. This is the process that we typically use out in the field. A minimum of 4 shots per angle, I think, is a good rule of thumb. It's the way I was taught. If we had something that was really critical, like we were setting anchor bolt patterns in a slab pour, let's say for a huge piece of equipment,
right,
a real high-tech piece of equipment, my tolerances on those anchor bolts may be 1/1000th of an inch. So if I'm doing something and I'm turning angles to establish coordinates out in space, I may shoot that 8 times.
Just to keep
narrowing down till I get within what our margin of error is.
And our example here was just the first angle.
Right.
We could be turning a dozen angles to get around
right. So
a structure.
That's the beautiful thing about a traverse. You've got these known points in space. So it kind of, you know, it's just like a wall around what you're shooting. But off of all those points, I have coordinates. So I can utilize this, I can set up on a traverse point, and because I have all these other points, I always have points of reference to start up, and I can do the trig or the geometry it takes to know what I have to turn, what I have to tape out for distance to set whatever we're trying to establish.
Because all those traverse points set straight lines that once we know 2 points, then we can set a third point.
It's like you can cut that job up into triangles.
Sure.
Which is perfect for what? Utilizing trig.
Right.
If I have a known angle and a known side, by using Sakatoa, I can always get You know, I can always find what a missing angle is or a missing distance is.
Okay.
Okay. And you're absolutely right. One thing is we would have done this, we would have moved from point here to point B and then done the same thing, and then we would have moved over to point C and
so
done
we
the same
could go
thing.
from, we'd move to B and we'd shoot C to A.
Right.
And then we'd move to C and shoot A to B.
Right.
And that way we've gone all the way around.
And that's what we're going to be doing in class.
Right.
So we just introduced the concept at this level.
Yeah, the process stays the same.
Right.
Right.
But we'll introduce you to the total station and then how to measure angle and distance off of one unit will be the south.